It's so great to see all of you here today. My name is Ram Pedibotla. I run the AMD's cloud server business. The topic for this session is something that's top of mind for all of us in this room. As we run infrastructure at scale and in production, how do we manage it effectively? How and when to modernize? What are the benefits and the trade-offs involved in that process are things that we will cover in this discussion. I'm really excited to have my colleagues from Netflix and Pinterest join me for this session. We have Neil Mullen from Netflix. He is the Director of Cloud Engineering, and he oversees the entire compute fleet for Netflix. We have Madhuri Racharla from Pinterest. She is the VP of Infrastructure, and she's in charge of the compute footprint at Pinterest. We have a great update, so let's get to it. We'll cover the agenda in 3 parts. I will talk about what AMD offers in AWS and how those offerings are the foundation for profitable modernization. And then we'll have Neil come up and talk about how Netflix is using AMD instances, their journey of adoption, and the benefit that they're seeing. And then we'll have Madhuri talk about Pinterest's experience in using AMD instances and the value that they're deriving from those instances. So let's start with why AMD. Let's kind of begin at the beginning, as they would say, right? AMD's mission is to drive high-performance computing. When you look at end customer devices like PCs or game consoles, or in the network that powers the wired or wireless infrastructure, or deep in the data center, whether it's cloud or enterprise, AMD pushes the envelope on performance. When you focus specifically on the data center, AMD has the broadest portfolio of high-performance compute engines for the data center. From CPUs to GPUs to DPUs and FPGAs, we have industry-leading products in each of those categories. So the answer to the question why AMD is very simple, because we drive performance and price performance advantage to you. Now, what does that performance actually look like? One example is the 7A instance family at AWS. When AWS announced the 7A instance family in summer last year, they completely redefined what performance means in public cloud. These 7A instances are based on AMD's 4th gen EPYC processor that we've codenamed Genoa. When AWS and AMD got together to collaborate on how best to bring Genoa to market, we had a very simple goal. That is to drive performance and price performance leadership within the EC2 portfolio. When these Genoa-based 7A instances came to market and became GA in August 2023, that's exactly what we accomplished. 7th gen instances deliver 50% more performance than the previous generation. This is enabled by a combination of AWS's Nitro subsystem along with the performance and the capability that we at AMD have built into Genoa. And that combination allows us to bring very, very compelling instances that provide that much of a performance uplift. 50% uplift in one generation is the most that anyone has ever seen in the industry in one generation. That performance, by the way, is an average across a number of workloads. When you look at specific workloads in the enterprise, like databases, like web front end, or your Java-based applications, your performance advantage is even higher. So when you look at the 7th gen instances, they deliver dramatic performance that is a step function from the previous generation. Now, what does that performance look like in real-world deployments? So let's look at a competitive compare to the instance family that has the broadest existing footprint of legacy instances, which is M6i. This family is based on Intel's Ice Lake processors. When you compare an M7A Genoa-based instance to an M6i instance, the performance difference is 2x. M7A instance is 2 times the performance of an M6i instance. And this is across a number of different workloads. This is not a synthetic benchmark measure. That much performance difference means you're able to get the same amount of work done in a smaller instance footprint. That allows you to reduce the number of instances that you're using. So if you're using 1,000 instances for M6i, you can get the exact same work product for 500 instances for M7a. And that results in dramatic OpEx savings, about 37% OpEx savings just by using M7a instead of M6i. And this is very, very easy to do. It's x86 on both sides. There is no core porting involved. It's almost a push button, and you have this tremendous OpEx bonus that you have by adopting M7a instances. A number of customers of ours have utilized these instances to derive these cost savings while achieving better performance. You'll hear from Netflix and Pinterest today. You'll hear from Pixar and Epic Healthcare in our booth and other sessions later tomorrow. So these customers span the full spectrum of uses. And we have another example on the slide here, Amagi, which is an M&E company that has accrued dramatic savings for their video services. And we have Neural Magic that is showing extreme performance benefit of M7a instances for their sparsity-driven AI inference on CPU workloads. Now, when you look at what is the business impact of that kind of performance, one thing we have noticed, by the way, as we talk to our customers and partners, and when you scour the research papers as well, there is a very stark difference on how OpEx gets allocated in an enterprise. We see that about 2/3 of the cloud OpEx goes towards that gray box of the pie, which is the general purpose IT. So this is just maintenance, this is IT overhead to get the business running. So this is cost of doing business. It keeps the lights on, but it doesn't really add to the bottom line. It is not customer-facing business value-add applications. It, in fact, actually subtracts from the bottom line. Now, when you look at the rest of it, only 1/3 of your OpEx is going towards customer-facing applications that are driving the revenue. That delta potentially varies from company to company, but that bifurcation exists in all of the deployments that we encounter. And one of the interesting parts, by the way, is that the general legacy IT overhead usually runs on older instances. The mentality is, hey, it just works, it's deployed, why touch it, why distract from it, let's keep it going. A big mistake, because that is a sinkhole of cloud OpEx. Now, if you take that sliver of your OpEx and update it to an M7a instance family, you shrink that portion of the OpEx dramatically. In fact, you will achieve 27% of what you previously spent on that gray band. Now it's freed up, and it can go into that blue band. It becomes value added. This is something that you can invest in consumer-facing applications, whether you want to grow capacity or you bring on newer applications. And of course, all of us are under tremendous pressure for one specific class of new applications that we need to bring online, which is generative AI. AI came onto the scene, but didn't quite bring its own budget. This is one way to make room in your OpEx to deliver these AI pilots and AI projects that you're under pressure to deliver. Now, when you step back from that, what you see is a distribution that actually makes more sense. A majority of the OpEx is now directed towards customer-facing business value-add services, and a minority is towards your maintenance. By the way, this is a journey that you can continue to push on. You can modernize those business-facing applications as well, and you will save OpEx there that can in turn be plowed back into additional services. That is the fundamental business benefit of performance-driven cost savings that come with modernizing with AMD-based instances. It's to do more with less. You're able to get the same amount of work, if not more work done, with a fewer instance footprint that allows you to save OpEx that you can in turn plow back into your core business to accelerate your business growth. That is the modernization with an intent. It's not modernization just for the sake of it. It's really modernization in service of driving innovation forward. It's a simple three-step formula. First, just get cost optimized by modernizing those instances from legacy instances. You can either get your jobs run faster or do it with a smaller instance footprint. Either way, you're saving money. That money can be anywhere from 37 to 45%. We talked about 37% in the previous slide. That is pure infrastructure savings. So just going from 1,000 M6i instances to 500 M7a instances, you're saving 37% of your cloud OpEx. But usually, there's software licensing involved. And software is licensed by either core or vCPU. If you're using fewer instances, you are paying that much lower software licensing costs. And that adds up to the savings. So if you take the software savings into account, your savings can be a whopping 45%. And this is just by modernizing from one version of x86 to another version of x86. What you do with that, you take those savings and plow back into your business, into projects that you've always meant to drive, but you never had the OpEx headroom to do so. That is the fundamental benefit of modernizing with AMD-based instances. Now, we talked about the performance that the AMD instances provide, the performance-driven cost savings, and what's the business benefit of that. What are those instances? How do you pick what's the right instance to choose from? AMD has two instance families in EC2, both of which drive cost savings to end customers. One on the left-hand side is the 7A instances that I've talked about. These are based on Genoa. They drive cost savings through higher performance. So that's performance-driven cost savings. The other on the left, these are based on AMD third-gen EPYC CPUs, and they drive cost savings through price. So there's a performance-driven kind of price performance advantage, and there's a price-driven price performance advantage that's available to you. What you use on the left-hand side are latency-sensitive, performance-hungry applications. There's one other performance data point here, by the way. That's a Redis performance. It's 2.2x compared to M6i. These are very, very large numbers that allow you to save a tremendous amount of OpEx. And on the right-hand side is Milan-based instances that are 10 to 45% cheaper than a comparable M6i instance, and they provide equal to nominally better performance. So we're showing here that these instances are 5% better performant than an M6i on a spec and rate perspective. So you have two options to choose, both of which drive cost savings, both of which allow you to derive that cost savings and reinvest back into your business. Now, when you've now kind of on the journey of, hey, I picked an instance, I want to migrate. How does that migration look like? It's very, very simple and easy with these instances because of the x86 compatibility. It's the same ISA on all sides, and it's almost push-button simple. There's very little porting involved, almost no porting usually, and in general, very little optimization involved as well. And this ease of adoption is super critical because it allows you to move fast. And the speed actually comes in two flavors. One is just the speed of adoption itself in terms of how quickly can you turn over. So no porting, very little optimization means you can turn this on very, very quickly, almost push-button simple. But the other part is, do you have the skills and capabilities to actually undertake something like this? Given x86, that skill set is there in every IT shop, in every business in the industry. So you don't have to hunt for talent. And we all know lack of talent is where the best strategies fall short. So when you think about adopting modern instances to drive cost savings to reinvest back in your business, AMD instances are the most logical choice because of that compatibility. x86 ecosystem is extremely robust and broad. It's the broadest ecosystem that any one of us has ever engaged in our careers. It is deep, it is very large, and it's diverse, and it really spans the entire gamut of software, from tools, libraries, to all sorts of applications, from open source to proprietary. That's something an alternate compute architecture can't quite say. They will have gaps in either the breadth or depth of the software that's available to you. And one of the things that we hear often is when people embark on a porting project, you discover the dependencies that you never were aware of before you started that project. There is always that library that's hiding in a nook and cranny that just worked forever, that now you're stymied by because it needs to be ported. Imagine you're in the middle of a costly update process and you encounter that. That is a gruesome thing to face. Instead of going through that trouble, you can get the same or better cost savings on x86 instances with AMD with push-button simple adoption mechanism. If you put all of this together, modernizing is traversing from the left-hand side to the right-hand side. It's moving from the legacy mindset to be very intentional about choosing the CPU that your infrastructure runs on and utilizing that to right-size your infrastructure. It's moving from older generation instances to newer AMD instances and realizing cost savings as a result of that right-sizing. So you go from bloated, slow infrastructure that is costing more while performing less to a slimmer instance footprint that is more performant and that's saving you OpEx that you in turn reinvest back into the business. So that's the overview of what AMD instances in AWS can allow customers to do. Now I'd like to welcome Neil onto stage to get us an overview of how Netflix is getting these benefits. Here you go, Neil. Thank you.
Hey, good afternoon, everyone. My name is Neil Mullen. I lead what we call cloud infrastructure engineering at Netflix. And I'm going to talk a bit about what we've done in the past year or so in terms of modernizing our fleet and adopting a lot of this. So, looks like the animations aren't working. This was supposed to be animated. We got a lot of compute at Netflix. We've got a much denser, much greater proportion of our bill is spent on compute than at many other places. We've got a website that serves over 250 million subscribers, each of those subscribers with many profiles, so our reach is closer to 1 billion actual user profiles. Running a website at that scale with that many users takes a lot of compute. We've got personalization to make those menus so that we know what you want to watch before you do. That takes a lot of machine learning, which takes another lot of compute. We've got an almost infinite backlog of encoding that we want to do for video. We're not alone producing ever more video every week as we launch more, but we're constantly re-encoding the entire Netflix catalog at new resolutions, new densities to 4K, or optimizing it to take it the latest codecs. And finally, we've got a rapidly growing advertising business, which if we look at other companies in that game, we see advertising taking as much as 40% of their compute spend. So across all of these spectrums, we have a huge and very dense amount of compute. To do this, we use just about every offering AWS has. We have a massive amount of different sizes of EC2 instances. We have a large multi-tenant container service we built ourselves, running a huge amount of our services. We've serverless, and we've machine learning infrastructure, GPU-based, to back some of those workloads we talked about. So what attracted us to Genoa? First off, the offering. We've got real cores, not vCPUs. So for this very dense compute workload that we're kind of talking about, we've got the potential of driving much better performance through those real cores. In theory, we've got the best-in-class single processor execution of an AWS instance. And we've got these really large SKU sizes for those multi-tenant container fleets we talked about. We can run 256 real cores on a single box. We can do 128 cores without having to deal with NUMA boundaries or problems there. So on paper, there was a lot that really excited us about Genoa as we heard about it. From our perspective, We're very interested in startup time, rapid scalability. The Netflix business is getting a lot more dynamic with the kind of stuff we're doing at the moment, and scaling up and down our service, dealing with peaks and troughs, has become a much bigger priority for us in our business this year. We obviously want to drive ever better price performance in our fleet. As it happened with other priorities coming into this year, we actually had quite an old fleet. 90% of our fleet was actually sitting on Generation 5, and the remainder was sitting on AMD Milan, which we'll talk about in a moment. So we had experimented with Milan before. We found that as you crossed the chiplet boundary, that the price performance started not to work out for us at those larger sizes. It is the most price performant instance at those smaller sizes, and where we have non-CPU bound instances that require a vert boundary rather than just a container boundary, Milan has been our go-to. But at those larger sizes, it just wasn't there for us. However, the animations are completely broken here. We got this quote coming back from my performance team. The M7A shredded our benchmarks, exhibiting performance that transcends a regular generational improvement. Got really excited now on paper, not just on paper, but now starting to see it in reality, what Genoa was delivering for us. We saw that best-in-class single-threaded performance, coupled with that very heavy compute workload we have. This starts to look very interesting. And right across the board, all those 8XL problems and above that we saw with the chiplet architecture in Milan, they disappeared. And that performance continued right up the sizes. It's not all bed of roses. We still see NUMA density challenges, not any different than we see on Sapphire Rapids or anything else. But because of the large SKU size, our sweet spot at this time has actually become the 24 8XL 128 core box, because without having to deal with NUMA at all, we can still get 128 cores. Equally, something that plagues both Genoa and Sapphire Rapids is how the AWS have set things up at this time, that we see downclocking as you run these boxes really hot. And it's a bit of a step function down that, lends us to run some of our services a little less hot than we would really like to. And we hope in future generations to be able to smooth that downclocking curve so that we can run things ever hotter. So with all of this in mind, let's step in and look at some of those buckets of compute we talked about and what we actually saw. So we're supposed to be looking at just the first graph, but here, this initial performance benchmarking runs comparing the performance of Genoa in blue versus existing CPUs that we would have had in our fleet. Other CPUs in blue, Genoa in red. We see here that this is one of the personalization workloads. It's the second largest consumer of CPU in our fleet. In this case, per instance, on our prior architectures, we would have run our ASGs with about a 45% threshold, because on the right you can see we start to get latency degradation as we're exceeding those levels. We run at about 800 RPS per box. And as you can see, running Genoa at the same, we're not even breaking a sweat. We're at 20% CPU. We also have this concept at Netflix we call squeeze testing, where we push things to the point of breaking. So we start to run the same workload through squeeze and see where we get. And it gets super interesting as we start to look at the graph on the bottom left here. So we see, first off, that we can crank things up. We can get to 45% CPU usage, as we used to. We can crank things up further, and we can get to another plateau around 60% CPU usage, where we're cranking 2200 RPS through the same configuration. We crank it up again, and we start to get, you'll see the latency on the right. Things start to go sideways, 75, 80%. We crash the process at that point. Where this leaves us, though, is a really cool place. Rather than running our ASGs at 45% CPU usage as we have in the past, we can very confidently turn them up to 60%. That's a 33% gain right out of the gate. At the same time, it's not just a 33% gain. That's how you would measure the CPU. We are doing 2200 RPS rather than 800 at that point. That's almost 3x gain on this particular workload, the second largest consumer of CPU at Netflix. So that's been super interesting in this dimension for us for this particular workload. So let's go on. We talked about encoding earlier, which is the largest consumer of CPU at Netflix. And we're interested in the scalability. We run our encoding kind of like a serverless platform internally, where we batch up these, or chunk up this infinite supply of work into jobs that we run at very high density in containers. Here, what we're interested in is how tight can we run all these chunked jobs before we start to see variance in the latency, because that leads to a sort of fan out, if you imagine, of the high percentiles one after another. So we want consistency. But in this case, we can run at very tight consistency at lower throughput or at lower execution time than we would have seen before at 64 containers. We get up to 96 containers and we're beginning to see a bit of variance. But this is way better densities than we would have achieved on prior architectures, largely down to the fact that we're getting a real core for each vCPU. So again, our encoding performance on Genoa looks way better than we had seen in the past. And these are our biggest workloads, or they're our biggest price performance gains. But as I said, our number one priority going into this year has been startup time. We're doing a lot of interesting stuff at Netflix, which means we need to scale up and down really fast. So we went on a mission this year to kind of drive down the startup time across our fleet so that we can scale much faster. And this is the aggregate across about 450 microservices, which forms the heart of Netflix streaming. There was lots of work in here. This is not all Genoa by any means. And you can see the gradual wind down of the high percentile startup time in US East 1 as we move one service after another. But you can see the impact of Genoa in the next two regions. In about March, you can see the rapid drop there, where we flipped almost 1 million CPUs in 48 hours to Genoa. And that's the raw impact to the high percentile startup time, which enables us to scale up and down much faster than we've been able to do in the past. So it's been a really interesting journey this year with a lot of promise. And I think we've only scratched the surface. I think we've optimized what we can. We've dug in a bit. We've seen a lot of promise. But we're really excited to dig in really deep and do the kind of optimization work over the next few years that you've seen us present here in the past with Intel, for example. We've spent a number of years heavily optimizing, even introducing custom instructions for encoding. And we're excited by what we've got so far in 1 year with Genoa and getting into that sort of work in the next few years. So overall, Genoa has proved a really exciting platform to deliver the best in class of what's out there of Gen 7 instances right now. And we're excited to see what comes next. Thank you.
I'm not going to try animations, but I am going to start with Pinterest images. Imagine a world where creativity knows no bounds, where millions gather every day to share and discover endless possibilities. At Pinterest, our mission is to create everyone the inspiration to create a life they love. Hi, everyone. I'm Madhuri Racharla. I'm VP of Infrastructure, as Ram introduced me. I'm very excited to share our journey in adopting M7A Genoa instances, both for performance and cost benefits at Pinterest. So first, let me start a bit about Pinterest. With over 537 million people using our platform every month, Pinterest is redefining inspiration on a global scale. We are not just a platform, we are a movement that brings creativity and discovery to life. Each week, we have 1.5 billion pins saved on our platform, which showcases the Pinterest as a dynamic hub where creativity thrives and ideas come to life. In Q3 2024, we have achieved substantial revenue growth of 898 million, underscoring the success of our strategic initiatives and our ability to monetize our platform effectively. Pinterest continues to lead by focusing what truly matters to our users, advertisers, and pinners. At Pinterest, we are not just imagining the world of endless possibilities. Together with our user community, we are actually turning inspiration into action and dreams into reality. So let's talk about the powerful infrastructure that supports Pinterest on AWS. In fact, Pinterest is born in AWS 13 years ago. Ever since, we use tens of thousands of AWS EC2 instances every day. We not only rely on EC2 instances, our data is also huge. We have close to exabyte size of data that's stored in S3. This keeps all of our user ideas, images, user information, boards from our users in a secure and always available manner, which also helps us power our incredible recommendation engine. Over 300 internal services power Pinterest behind the scenes. This setup helps us not only roll our new features quickly, while keeping our platform reliable for our users all the time. Everything works together through our shared services stack. It keeps all of our systems connected and running effectively, and also the resources used efficiently. It also helps us with the developer velocity for our engineers while keeping our services efficient. This combination of scale, complexity, reliability allows us to deliver an empowering environment for our Pinterest users. So why do we care about performance-driven cost efficiency? Pinterest is growing fast, and we are dedicated to keeping our platform seamless and virtually engaging. Given our infrastructure scale and the impact on our expenses and margins as a business, efficiency efforts take a higher priority for us as well. Pinterest heavily relies on AI-driven recommendation models and also visual discovery engine. Hence, it's important for us to balance between the cost efficiencies and also performance of our infrastructure. At the same time, we always aim to provide highest quality of our services to our customers, and which are pinners, advertisers, and partners, meaning our 300 plus internal services as shared earlier has to meet our strict SLOs. This implies that not only just the price of infrastructure matters, but also performance matters equally. In other words, how can we keep our infrastructure costs lower by maintaining or improving our services to our users effectively? This is the challenge we were trying to solve for, hence AMD Genoa M7a instances came into play. We evaluated our infrastructure and identified potential opportunities. When we did the benchmarking with M7a instances, as Ram mentioned earlier, it not only offered 1 to 4 ratio through vCPUs to memory ratio, it is an ideal balance of our price performance. So M7a performance is so good that it unlocks vertical scaling. What that means is that it delivers a better results for our compute-intense workloads. For example, we were able to go from 100 C5 9XL machines into 90 M7a 4XL, which would yield about 35 to 40% price performance improvement. Simply put, AMD M7a instances combine exceptional compute power, efficiency, and cost effectiveness, making them an asset for us to reduce our infrastructure costs overall. So let's dive a little bit deeper into the vertical right sizing that works for our services that are running on C5 instances. We try to match the amount of memory per instance as close as possible. So instead of C instances, we can use half-size M instances, thereby reducing the number of vCPUs, which drives per instance cost much lower. Since there is no hyperthreading on M7a, the physical core counts are kept similar as well, even though we reduce the instance sizes by half. This is because there is a substantial IPC, instructions per cycle, uplift between C5s and M7as. The key takeaway here is that though M7a instances per hour core rate is slightly higher, the savings from performance improvements, when right-sized correctly, outweigh the cost. So how was our migration journey like? We have actually taken 5-step process. First, we understood our workload requirements, analyzed the services CPU, memory, and performance metrics. Second, instance type selection. We evaluated and identified the target instance types. Example, M7A in my previous slide I mentioned, based on the workload metrics and cost efficiency. Third, testing in staging environment. We deployed target instance types in staging environment, and we checked for compatibility and performance. And fourth, updated auto-scaling policies, adjusted policies to accommodate for the new instance types and make sure that the cost efficiency and the performance meets our expectations. And fifth, we need to set up monitoring to make sure we capture all the metrics, and we continue to monitor to make sure it meets our expectations. As you can see in the chart to the right-hand side, which is, by the way, one of our microservices CPU-bound workload, CPU usage remained consistent throughout the migration. Minor CPU spikes did not impact performance or SLOs. Migration from C59XL to M7A was completed in less than 48 hours, which is very impressive. And then we started monitoring our performance to make sure that it actually meets our expectations, and we did not see any issues whatsoever. So the step-by-step approach ensures smooth transitioning between C5s to M7As with a minimal impact. So in summary, we chose M7A instances with the AMD EPYC Geneva CPUs to boost not only the performance and also lower our total cost of ownership, which is our TCO. This strategic decision was made to improve both cost efficiency and performance. The goal was to better performance at a lower cost, and this delivers exactly that. By vertically right sizing, we achieved 35 to 40% improvement in price performance. This optimization not only improved our current efficiency, but also gave us a headroom for future improvements. At Pinterest, we continue to push the boundaries of efficiency and growth by making thoughtful and strategic decisions, and we greatly appreciate the partnership with AMD to help us improve our infra efficiencies. Thank you.
All right. Thank you so much, Neil and Madhuri. It is so great to hear about the lived experience of customers as they go through the journey of adopting AMD Genoa instances and the benefits that they derive from it. You know, on a personal note, I've been part of the Genoa program from its very, very initial conceptions. As you can imagine, a server processor takes many years to bring to market, all the twists and turns. To see all of that, for us to launch the processor, get it into a very compellingly defined AWS instance, and customers deriving benefit from it is one of the most gratifying things that I've been part of. It's really cool to see. And thanks again to Neil and Madhuri. Now, let me just quickly summarize in maybe just a couple of slides, right? Do more with less. That's the mantra. You're able to do equal or more amount of work with fewer instances and leverage that to drive your business. You can do that with two choices in AMD-based instances at AWS. One is the 7th gen instance that we talked about, 7A instances, and there's two kinds of cost savings you can get. One is just straightforward speed up. Your job gets done faster, so you pay less and you derive those savings. The second is you just get done the same amount of jobs that you did before, but in a much slimmer and a more efficient instance footprint. You save money that way too. So that's the performance-driven cost efficiencies, and that's kind of what Pinterest and Netflix have been able to kind of garner for themselves. The other side is just straightforward price-oriented cost savings. So I talked about Milan-based instances that just drive better pricing and lower cost, and then derive cost savings to you through that mechanism. Both of those allow you to get a modernization with an agenda, modernization with a perspective of driving innovation and accelerating your growth. That's the end point here. You can cost optimize your IT footprint by adopting the modern instances, drive OpEx savings that you in turn can reinvest back into the business. And you've heard that both from Netflix and Pinterest and how they were able to take advantage of that. And that's the one last thing I want to leave with you is by adopting these instances, you're able to do the same or better amount of work with an easier and a faster and a slimmer instance footprint that saves you money, that you can reinvest. And you can do all of that very, very easily. 48 hours is incredible in terms of a migration. And that's something that's available to you at your fingertips. So with that, just one little plug for the rest of the programs that's coming up. Please do stop by the AMD booth as you go through the rest of the conference. We have a number of lightning talks from AWS, from Pixar. We actually have Pinterest doing a lightning talk on Wednesday at 4:30. So please do stop by our booth. Second, please get on a wait list. We have a very, very compelling event tomorrow night that's headlined by 50 Cent. I hear it's fully sold out, but you should get on the wait list. And with that, let me just open up for questions. I'd like to have Madhuri and Neil come up if they're able to, and if you have any questions. Thank you all for your time.